Hello everyone and welcome. In this video I'm going to be explaining camber kits. Now camber kits are obviously used to adjust camber and you would want to adjust your camber for probably one of two reasons. A, you may have lowered your vehicle and then because of lowering your vehicle it offsets your camber, creates negative camber, so you want to put it back to your original manufacturer's recommended wheel alignment. The other option is you may want some negative camber for better cornering capabilities if you use your car for track use. So here we have a scenario where we're going to be lowering the vehicle. So here we've got our tire, we've got our lower controller arm, upper control arm, the knuckle connecting it, the coil over here, and here's the body of the vehicle in green. So what we're going to do is adjust this coil over and lower the vehicle down. So as we lower it, you can see there's the small amount that we've lowered it. As you lower it, it forces this, as this control arm pivots up, it's going to pull this in and it's going to induce a negative camber onto this tire. Now it's slightly exaggerated of course, but basically this is the idea of what's happening. So what you're going to do is you're going to adjust this knuckle where it connects here, the ball bushing on the control arm, and you're going to push that forward, and as you push that forward you can see it straightens out the tire, and so you can lower your vehicle and have the tire at the same recommended tire wheel alignment camber that the manufacturer suggested. So you've got your stock vehicle, you're lowered with negative camber, and then you've repositioned the ball joint on the control arm so that you can have the stock camber adjustment. So what this looks like basically is here we have our control arm. This is going to be the front control arm, and it's on it has a slide here that this ball bushing can move on, slide along. So that's what you're going to be adjusting in order to push that knuckle forward so that you even out the camber. Now the reason I went with this Buddy Club camber kit rather than some of the others was basically because it had a solid metal in the center here. Some of them have a hole cut out here, and basically these screws that hold the ball joint in place, they're on this very thin piece of metal right here. You can imagine this being cut out. And I just thought, well, if you get a high enough stress on that, it may bend or deform. It may not last for a very long time, so that's why I went with these. Now, is that the case? I don't know. Maybe they are. Maybe they can last fine, but it just seemed like this was an extra guarantee of nothing's going to basically bend or warp here over time. And here we have the rear camber kit. So this will be the upper control arm for the rear of an Acura Integra. And so basically it's just a threaded rod, and you can rotate it to the length that you want to set the camber at. Now, if you lower your vehicle significantly and you have too much negative camber, why would you want to get rid of that? Well, several things. If you have too much camber, first of all, you're going to have uneven tire wear. So since the tire is going to be resting on that inner edge, or putting primarily most of the weight on that inner edge is going to wear more than the other side, so you'll have uneven tire wear. Also, you're going to have reduced traction because you're going to have a smaller contact patch or more of your weight on a smaller contact patch on the ground. And because you've got less traction, then you're going to have reduced braking, and if your vehicle is traction limited because your tires spin if you accelerate, then you're also going to reduce your acceleration. And then one other thing that could happen is your tires could tend to follow grooves in the road. If all the weight's in one very narrow spot, it'll just kind of follow the road more. So, why might you want some negative camber? Well, it can help in certain situations. For example, for cornering speeds when you're going all out in cornering, basically taking high G-force turns. So here we've got, we're looking at two tires, one without any camber and one with negative camber, and we're going to be taking a hard right turn. So we're turning this way really hard. What's going to happen is we've got this tire here on the left, and this tire is going to deform as you throw it into that turn due to the friction with the contact patch on the ground. So as it deforms, it's going to kind of end up leaning over towards this sidewall, and the tire is going to deform kind of how I've marked here in red, and part of the contact patch may even be lifted up off of the ground if you corner hard enough and you've got enough grip. So obviously you don't want to run onto your sidewall. They weren't meant for running on the ground. That's why they're on the sides of the tire. And also with a smaller contact patch you're going to have less grip. So if you have negative camber, and this is slightly exaggerated but it's just illustrating a point, if you have this negative camber and you throw it into a hard right turn, as that tire deforms, it actually evens out the contact patch perfectly with the ground. So at a certain point there's going to be a certain angle which, if you go around a corner, let's say your car can handle a 1G turn, well at 1G your tire will deform a certain amount, and you'll want to set your camber so that it deforms the exact amount so that it doesn't run onto the sidewall at all, and it just has a perfectly flat, full width of the tire contact patch, so you have maximum traction and can go around the corner at the greatest speed. Now, like I said, this is for high G-force turns. This isn't something you're just going to be doing driving around on the roads, on your way to the grocery. So basically this applies for track cars, or if you use your car for something like autocross. If you have any questions or comments, feel free to leave them below.